So we're going to continue today solving inequalities. Today we're going to do one step with multiplication and division. If you need to look it up, it is chapter 6, lesson 7 in your book. Now, throughout all of this, I've said they get done the same way, they get done the same way, and that's still true for solving with multiplication and division. However, when there's a negative involved, it's a little tiny detail that makes a huge difference. Okay? I've summed it up by saying when the coefficient is negative, the symbol flips. And I'll show you examples of what I mean by that in a minute. I use this word coefficient kind of loosely because in some cases it's not going to look like a coefficient, even though it sort of kind of is. And again, I'll show you some examples. But when the number with the letter, is negative, not just that there's a negative in the problem, but the number with the letter is negative, you have to do something different. Okay, let's look at our first one here. This is a straightforward, simple multiplication 8x problem. There's not a negative to be found. We're just going to do like we've always done, right? So here we split it. I see this as multiplication, so I'm going to divide. I'll be left with x, because that goes to 1. That's what we want, just x. 40 divided by 8 is 5. And because there was no negative anywhere to be found, I will bring down the exact same symbol that I started with. X is less than or equal to 5. And of course, if you wanted to graph it, there's 0, there's 5. It's allowed to equal it, so we'll give it a solid circle. And I want all the numbers smaller than 5. So 4, 3, 2, down into the negatives like that. Pretty straightforward. Now, our second example, again, not a negative to be found anywhere, but this time this is division. Remember the fraction bar? Sometimes it's a fraction bar, sometimes it's a division symbol. So right now, D is divided by 2. So to undo that, I'll multiply by 2 on both sides. On the left, the 2's will cancel out, and I have just D. On the right, 7 times 2 is 14. Not a negative to be found anywhere, so I'll drop my sign down exactly as I say it. D is greater than 14. If I wanted to graph, I'm going to have an open circle because it's not allowed to equal 14. You can see my old habit of writing it above the number line. And then I want all the things bigger than 14. All right, you can see how sometimes that's a little bit easier to see than when you put it on the line. All right, those were two very straightforward problems, one multiplying, one dividing. Undo what you see, we're good to go. Okay, now if you wanted to check, of course, you could pick a number like, I don't know, pick 100. 100 divided by 2 is 50. Yes, 50 is greater than 7. We're good. All right, now let's toss in some negatives. Here, our problem is negative 2g is less than 10. To start off, everything happens exactly the same. We still split it. We're still going to undo and divide by that negative 2. Two negatives make a positive. 2 over 2 is 1. We're left with just plain g. Yes, that's what I wanted. On the other side, 10 divided by 2 is 5. There was a single negative sign. Now, there was a negative number attached to my variable, which means the symbol I started with reverses. It started point and then went big. I reversed it to big and then point, which is so not a technical term, but you know exactly what I'm talking about, don't you? So I think my answer has to be greater than negative 5. Let's check that. Give me a number that's greater than negative 5. Personally, I'd go with something easy like 0. 0 is greater than negative 5, and you better believe it's going to be easy to work with. Let's test that. If I do 2 times 0, do I get something less than 10? Remember to check, I go back to the original problem, and I put in what I think my answer is. I think my answer could be 0. Is negative 2 times 0 less than 10? Yes, it is. So anything that is larger than negative 5 will make this work. Now, what if, let's do a what if I forgot to switch it? I'm going to do it on this piece of paper right next to it so I can move it. What if I had gotten g is less than -5? Well, let's pick something less than -5. I don't know, -10? Let's say that -2 times -10, is that less than +10? Well, let's see. 2 times 10 is 20. Two negatives make it positive. Is 20 less than 10? No, which means that was not right. The easiest way I can explain this, other than just showing you the examples, the easiest way I can explain this is that, remember, negatives make everything behave the opposite. So if you're going to multiply and divide by a negative, you have to make this symbol do the opposite. That's the easiest, without getting into a big, huge description about it. That's the easiest way. You kind of have to have two things to be able to cancel each other out. So we've got a negative and we've got a reverse. Now, of course, if I wanted to graph all my possibilities, the right marker here, we're going to have 0 and we're going to have -5. This gets an open dot, and I want all the things bigger, and that will give you all your possibilities. -4, -3, -2. There's that 0 that we tested, and of course, all the positive numbers. All right, let's try one more of these. So the original problem here is x divided by -3 is less than or equal to 4. Again, they all start off the same way. We split it. We're going to undo what I see. Since this is division, I'm going to multiply by the number that's attached. So here, the -3 and the -3 cancel out, and I'm left with x. On the other side, 4 times 3 is 12 with the negative sign. Because the negative was attached to the letter, the symbol in the middle must reverse. So I started with a less than or equal. Now I'm going to go to a greater than or equal. Can you see how they flipped? Let's test it. Give me a number greater than or equal to -12. I can equal it. I might as well stick with -12. But okay, let's do something greater. Let's say 0 again. I love 0. 0 and 1. If I get the choice, I go for 0 and 1 every time because they're super easy. So I'm going to go for 0. Let's say 0 divided by -3, is that less than or equal to 4? And I put the question mark to show that I'm not sure yet. Well, if I have nothing, I don't care how many piles I divide it into, I'm still going to have nothing. Don't put a negative sign in front of that. Even though there's only one in the problem, -0 doesn't exist. Is 0 less than or equal to 4? Yes, which means that's correct. And if I wanted to show a picture of all the possibilities, there's 0, and I'm going back to my answer here. -12, solid circle, because it could equal it, and I want all the things larger than -12. Now, I want to show one more. I'm not going to go through and do the whole problem, but I want to show you one more situation. Let's say that I had m divided by 24, that's a 2, believe it or not, that's a 2, is greater than -6. My question for you, would the symbol flip? When I was all done and I was finishing up getting my answer, would I switch to that? Or would I keep it as it was originally? What do you think? I do see a negative in there, but is the negative number with the letter? Nope. This is going to stay exactly as it starts. Only when the number with the letter is negative would it flip. Now, if I had this, flip away, because the number with the letter was negative. I don't care what the other side is. That means nothing to me. I'm looking at the number with the letter. Same thing if it was a multiplication. This would flip. This would not flip because the number with the letter is not negative. Little tiny details all over the place. Pay attention, slow down, don't be afraid to write things out.